Now starting. All attendees are in listen-only mode.
Good afternoon and welcome to our webinar on optimizing utility operations through the use of AWWA utility management standards. My name is Anthony DeRosa. I'm with the Association of State Drinking Water Administrators. I'm going to be helping to moderate through the webinar today. The AWWA utility management standards were developed to help utilities foster excellence through continuous improvement and evaluation processes. These voluntary standards and associated guidebooks allow utilities to identify gaps in their management systems and to help improve systems before they fail. Case studies have shown that through the use of standards, this helps utilities save energy, improve efficiency, prevent water loss, and improve water quality. They've also been used to successfully justify investments and secure funding. Today's webinar focuses on the G200 standard, which is Distribution Systems in Operation and Management. This is the second in a series of 3 webinars, which include a detailed review of the AWWA utility management standards and self-assessment guidebooks for treatment, distribution systems, and source water protection. If you think of any questions throughout the webinar, please submit them through the questions panel. We'll go over them at the end of both presentations. Our first speaker today is Eva Naminsky, who will give us a brief introduction and overview of the utility management standards. Many of you know Eva. She works for the Utah Department of Environmental Quality, where she provides technical assistance to water treatment plant managers and operators and conducts research projects on water quality and treatment. Eva's expertise includes many aspects of water quality and treatment, familiarity with small systems, rich background in microbial contaminant occurrence, detection, removal, and inactivation, as well as expertise of having designed and conducted projects that result in invaluable practical guidance for utilities. With that wonderful introduction, I will kick it off to Eva. It's all yours, Eva.
Thank you so much, Anthony, and thank you for such nice introduction.
Sure.
Thank you. Can you hear me?
Yes, you're coming in loud and clear.
All right. Thank you so much, and thanks to ASTWA for organizing this series of webinars, and of course, thank you to everybody who signed up and attended. I have the privilege to give a short introduction, and I'm trying to keep it short so that Ken would have time to focus on why we're here. Just wanted to make sure that we all understand the origin and the purpose of what we're doing and why we're doing. And it's, as Anthony said, this is the AWWA Utility Quality Management Committee, and we prepared a series of 3 webinars dedicated especially to state agency staff who are seeking tools and material to effectively help water utilities to optimize their operations. So we're trying to establish a better bridge, better communication between state staff and utilities, and have utilities rely and count on technical assistance from the state, providing the tools in form of those management standards. It's a series of voluntary standards, and they were developed by AWWA volunteers in several areas of utility operations, starting from source protection, treatment, distribution operation and maintenance, all the way to customer service, emergency preparedness, water conservation, and others. So these standards, as I said, are voluntary, and they serve utilities in conducting self-assessments on their selected operations. They help pointing out priorities, leading to better operations. These standards can be used in any order and over any length of time. We believe that regulatory agencies could provide valuable guidance to utilities in applying the standards by promoting their use and by helping out with the operational tools, so that this is basically why we invited you to this webinar, and we're thankful for your time with us. I wanted to start by showing you a full list of the utility management standards developed in AWWA. The left-hand side shows drinking water standards. The right-hand side shows wastewater standards. On the left-hand side, the first 4 on that list, those are standards that also have individual guidebooks that were developed and they're available. The standards on the right-hand side, the ones that are the last 4 that are written in italics, are still in the development stage. But when you look at the full list, you can see that these standards cover most, if not all, utility operations. And we hope that by helping you being familiar with the utility management standards in general, you would be willing to promote their use in the utilities in your state, and you would be willing to assist your utilities in using these standards and performing individual self-assessments. The one in red, the distribution system operation and management, that's the one that we're dedicating this webcast in the series of 3 webcasts. And this one is also known as a G200 standard. A quick overview of the nature of these standards. They are coordinated by the AWWA Standards Council and the AWWA Utility Quality Management Committee, which is composed of consulting engineering firms, engineers and scientists, utility operators and managers, and state and provincial regulations. The Council and the Committee worked over a decade to bring together groups of experts for each standard and give those groups of experts guidance on how to construct those standards that would serve in several areas of utility functioning. These groups of authors of individual standards, selected from utilities, consulting engineering firms, and state agencies, are well known in the drinking water industry. They're highly published, recognized in their respective areas of expertise, and they provided their time and expertise as volunteers in AWWA. All of these standards developed so far in various areas of operations are constructed in the same format, guiding the reader to a set of items to be considered in a self-assessment. These elements, those items to be evaluated, are non-regulatory, but they're set above existing regulations. So, for example, they indicate needs to develop standard operating procedures in some specific areas or to conduct periodic checks in other areas. They are ANSI certified and are reviewed every 5 years. These standards live in a family of AWWA standards, so all utility members of AWWA receive those standards as part of their membership, and they're grouped and designated as a G series standards, just a letter to be assigned to the group of standards. But they're still little known and not very well advertised, since they're not regulatory and not required. And as I said, 4 of those standards have guidebooks that help in performing self-assessments. There are several common threads that link those utility management standards. Other than the same format that I mentioned and non-regulatory set of optimization processes, these standards are written for the operators. They should be achievable by a well-operated utility at the moment of the self-assessment, and that is utility of any type, any size, including small systems, and without having to undergo any special investments. So in other words, a well-run utility of any size should pass a self-assessment against any of these standards with only minor recommendations that help continuing improvements. So these standards are not written for the best of class. A utility that checks its operation against the standards could request another utility or a state agency staff to perform a peer review of their self-assessment. Here in Utah, we conducted such peer reviews, and we could report measurable improvements of utility operations since the self-assessment resulted in measurable goals, achievements in optimization activities that were developed in projects that lead to better operations and thus better public health protections, all above and beyond what's required by existing state and federal regulations. The vision listed on this slide behind having standards that help utilities operating beyond and above the existing regulations is that conformance with utility management standards will enhance public confidence in their operation while demonstrating continuing improvement efforts. That's a big statement, big vision, but we should hope that several utilities could make that statement and prove that they deserve public confidence and are engaged in continuing improvement. I don't have to tell you that investment of time and money into optimization of utility operations brings huge benefits. It's a good investment. excellence in operations and continuing improvement are visible to the public and to public officials. They bring confidence not only to utility managers but also to the customers and the oversight agencies. Optimization efforts provide continuity in seeking improvement and measurement tools for evaluating that improvement and in prioritizing elements of this continuity in optimization efforts. So far, as of now, several water utilities in the U.S. have conducted self-assessments against several of those utility management standards. Some of the comments that were shared with us, with the Utility Quality Management Committee, stated that applying these standards to utility operations helps to manage utilities in a way which guarantees peace of mind. That's a big deal, to say it by IT utility. Using the standards in optimization operations assures continuity in optimization efforts, encourages development of standard operating procedures, and having those SOPs in place allows new, young operators possess knowledge that otherwise would be lost once older and more experienced operators retire. And finally, having and using a set of standards helps maintaining safe performance based on a set of good practices and not just good luck, allowing operators, managers, as well as regulators to sleep well at night. In Flint, Michigan had followed the minimum requirements for a corrosion control monitoring and had a plan developed by the G200 standard, the catastrophe in Michigan could have been avoided. We're very, very firmly believing in what I just said. So we're dedicating this webcast to the standard, the second one in the G-Series family, the Distribution System Operation and Management, also known as G200. And Ken Oberoi, who is the Director of Water Distribution Department in Charleston, South Carolina, was chairing the group that developed the distribution system standards. And he also was the author of the guidebook developed to facilitate self-assessment against the standard. So you'll hear from the prime source, and I should let Anthony introduce Ken, who will guide you through the elements of the standard and help you better understand the extent of questions that help in optimization of distribution system operations and management. So thank you so much. Back to you, Anthony.
Great. Thank you, Ava. All right. Our next speaker is Ken Oberoi, who will take us through the G200 standard for water distribution systems operation and management and the benefits that it's provided to utilities. Like Ava said, Ken is the director of the Water Distribution Department of the Charleston Water System in Charleston, South Carolina. He has a master's in environmental engineering from the University of Alberta and is a registered professional engineer. He's got more than 25 years of experience in the operation and maintenance of state-of-the-art water treatment plants and water distribution systems in the United States and Canada. He's a member of the AWWA Standards Council, chair of the G200 Distribution Operations and Management Standards Committee, and Direct Potable Reuse Standards Committee. He has served on various Project Advisory Committee, member AWWA-RF projects, and he's credited with developing unidirectional flushing techniques and has helped his utility to become the first water utility in the nation to become ISO 14001 certified. Ken, I'll let you kick it off.
Well, thank you, Anthony. I just want to confirm, everybody can see my slides right now?
Looking
good. Can you hear me loud and clear? Great.
Yes, sir.
Well, thank you so much, and thanks, Ava, for giving us a reason to why do we need these standards. What I'm going to do is talk about G200, which is AWWA G200 Standard Distribution Systems Operation and Management. Okay. The rationale behind the standard is to gain a better understanding of how the AWWA G200 standard can help optimize the operation and management of water distribution system. We've been operating distribution system for a long time and doing the best we can, but this standard set us up a bars we have to cross to make sure we are distribution system is operating to a maximum peak capacity and most efficiency. And also we can use this standard to identify the area within the distribution system which we can improve. The whole standard is written to make sure that utilities can look at the standard, find out where they are, and they can look at it to how they can improve and give them an opportunity for improvement. It's basically looking at a continuous improvement as you go. What I'm going to talk about today is a presentation. You'll be able to understand what G200 is all about. I try to make it as simple as possible. I'm not going to go into too much detail. I know you're not the utility folks are doing nuts and bolts of the standard, but give you enough information you understand what we needed. And if you have the standard and after the presentation, you'll be able to do yourself or help somebody to implement and incorporate the standard on a day-to-day operation. So agenda today is just look at the overview. And after the overview, I'm going to talk about 4 critical areas, 4 critical requirements of the standard and how to apply them in your own system, or you can help somebody to apply them. Okay, the very first thing that I ever talk about is a guidebook. It's a very good idea to get this guidebook. It's very economically priced. I'm not putting a little infomercial for AWWA. Originally, it was published in 2009, and it's still available. And the current standard is 2015, and still applied to most of the 2015 standard. The guidebook gives you a little talk about describe the scope, what the critical requirements are, and for how to effectively operate and manage the distribution system, and also define the critical requirements for maintaining a water quality in the distribution system, different management programs, and how to operate and maintain all the facilities associated with the distribution system. And also it gives the evaluation where we are at, our operational management techniques and policy and procedures we follow, and how we can improve them. Let's talk about the 4 different critical key requirements. Our biggest requirements are maintenance of water quality. Number 2, look at the system management program, which helps us achieve the water quality. And then we look at how to operate and maintain all our facilities in the distribution system to the peak capacity, most optimized ways, get the best value on the dollar, so to speak. And ultimately, we have to make sure we verify the audit to make sure we say what we're doing. Okay, I'm going to take it the first one, the maintenance of water quality. Number 1, the standard calls upon compliance with all the regulatory requirements. As you know, health and safety is a critical part of drinking water. And the person drinks a glass of water, they do not feel that, well, should I drink it or not? Everybody drinks it. Your kids drink it, your family drinks it, loved one drinks it. So every time you pick up a glass of water, everybody should be able to say with 100% confidence, I'm going to drink it and it's safe to drink. And I can say the same thing in a lot of other countries. And to do that, to make sure all the applicable legal and regulatory requirements are met, that could be in U.S. and state requirement or federal requirement, or in Canada provincial requirement, or any other local requirement. In addition to that, the standard calls upon you have to have a document to show requirements achieved. It's not just saying that requirements are met. You got to have a documented proof and documentation. And this standards talk about documentation throughout the process. Every time anything happens, you got to have a written documentation. In terms of water quality, you got to monitor the water quality. To have a water quality monitoring, you got to have a sampling plan. And the sampling plan has to be reviewed annually, and data has to be analyzed and trend established, and you have to make sure the sampling sites are safe, they are not prone to contamination, and so forth. And they're located at the right places based on the hydraulic detention time, different pilot material, and if whatever you need to do, you need to do. All the data you get based on monitoring the water quality and distribution system, you got to look at the historical data trends. Then you have to look at the trends and look at the changes in the water use pattern, where the demand goes up or low or high, what's happening hydraulically in your system. You got to have hydraulically and also water quality, basically modeling system which tells you on a random basis what how the water quality is impacted as the water travels throughout the distribution system. You have to analyze these trends, data trends, and based on the data trend, you got to come up with a response plan. Basically, you got to basically change the system preventatively. The whole standard calls for changing the distribution system preventatively because You don't want to be just like Flint. It's too late to change it. You got to find the problem ahead of time and correct it before it becomes a problem. Sorry, I'm going to go one slide further. Talk about maintenance of water quality. The standard talks about if you have disinfection residual maintenance in your distribution system, you got to have a detectable residual at all points in the system at all times. How do you find out at all times? You have some sort of monitoring system where you systematically monitor manually or remotely to make sure you have a detectable residual. In addition to that, you have to monitor disinfection byproducts. You can control them and monitor them. And if something happens, you have to have a written action plan established at a time to control in terms of DBP levels exceeded the goals, or you have a problem maintaining disinfection residual. Some of the utilities, they do not use this residual. There's additional requirements for them. It has to have HPC monitoring, which has to be minimum of make sure it's less than 500 CFUs all the time. And you have the systematically monitoring processes there. You take a sample and analyze them to make sure data is collected, analyzed, and monitored and reported. Let's talk about maintenance of water quality in terms of internal corrosion. Eva talked about Flint, and this standard basically go in quite a bit detail talking about these kind of issues so we can avoid the situation in Flint and other places. It talks about a monitoring and sampling plan for corrosion-related parameters, and you have to monitor pH, alkalinity, conductivity, phosphates, silicates, calcium, metals, asbestos, and a bunch of other elements. And you monitor them preventatively in the distribution system. It's a little bit beyond the requirement, legal requirement, what we have currently. You got to inspect your water distribution mains every time you expose or cut a pipe. You look at the internal pipe, what condition they are, and you have to make sure if the condition is not satisfactory, if there's a criteria to develop how to evaluate internal condition of the water main, how to condition assessment tool, which is built into the standard. And there's a detailed procedures to control lead and copper levels in the distribution system. In addition to that, there's a guidelines for controlling the other corrosion-related byproducts in the distribution system. And this inspection has to be done every time you have a cut in a pipe, or you are doing a corrective maintenance of a main break, or adding a distribution system, or modifying a distribution system. Okay, I'm continuing some maintenance of water quality. In addition to that, you have to concern about static water quality requirement, which could be color and staining. And in addition to that, there's a requirement for health-related taste and odor. Into the color and staining, you got to make sure you take the water sample. Every time the customer calls you, make sure you take the call. The people who are taking the call or responding to this call are trained personnel. It has to be done a certain amount of timely resolution of the concerns and problem. You have to collect the data and track the data, plot the data on your distribution system profile, and find the trends. Where all these problems are happening? What we can do with this problem? If the problem exists throughout the distribution system, then you need to come up with a plan to how to resolve it or reprimand. If the problem's only happening in a certain area of the distribution system, they have to find out what's going on, and you have to do an in-depth analysis and correct these problems. Similar to color and staining, you have to go about the taste and odor and other issues occurring that. To do that, you have to have a sort of a 24/7 inquiry call system where any customer can call in 24/7 and report a concern. Of course, I cannot talk about the trained personnel. Some of the calls comes in, a trained personnel can resolve it over the phone if the dispatcher is qualified. Dispatcher's job is not to just to take the call and pass on distribution personnel, but to collect as much data as possible from the customer so we can have enough information to resolve the concern adequately. If the dispatchers are properly trained, they can't do that. Again, timely resolution is of utmost importance, and every call has to be monitored and resolved and tracked and be documented. Again, we're talking about similar to color and staining aspects of it, track the data, train for the water quality aspects of it. You have a complaint database tracking, find the track and find the concern and resolve the problem. And you have documenting procedure to how you take care of all these things. I'm going to talk about a little bit more of a customer relation point of view because customers are the most important, these things we have in our distribution system. Basically, we are only exist because distribution system is because of our customers. I always say in our department, there's nobody's supervisor, nobody's boss. Our real boss is our customer. So we are here to make sure the customer is taken care of. So to do that, you got to learn for the customer, what kind of customer you call you, what kind of inquiry type they have. Find out what would happen, what the results were, and how you resolve the inquiry. And you have documented everything. And then you find the trend, resolve those trends, take care of the customer, communicate with them. You can communicate with them in a random way. You can have surveys, you have stakeholder meetings, you have focus groups, whatever you want to do. But you have to have an annual goal with the standards talk about to reduce the number of customer concerns or complaints. If like we have a complaint this year for certain areas, that we're going to have an objective for the next year, how we can resolve it and how we reduce it. Again, like I talk about, this standard is all about continuous improvement, finding opportunities of improvement and improving continuously. Doesn't matter where you are at, as you could be a lower level of the standard, but as long as keep on improving, you're going to be top of the standard one of these days. To do that, basically, this standard emphasizes is a major impact is a preventative maintenance program in the distribution system, which is basically a system flushing program. I call it systematic flushing. You can call it unidirectional flushing. It still has to be right. Sometimes you need spot flushing to concerned about the staining or color calls or water quality concerns, but the standard calls for having a unidirectional flushing, basically systematic approach to maintaining the water quality distribution system. And you can do that at the same time, preventing maintenance on the valves and hydrants, and you can collect the asset management data at the same time, and also you can audit the distribution system to make sure all the valves are supposed to be open, and you can do the condition assessment at the same time to make sure and all the infrastructure in your distribution system are the appearances are the condition they're supposed to be. And if you find any concern and problem, you should write the work order and send it to the corrective maintenance folks so they can come up and fix it. To do that, the standard calls for written procedures addressing all activity associated with the system-wide flushing, how to monitor the water quality, and how to monitor the actual distribution system and the condition assessment of the distribution system while you're doing the systematic flushing program. Let's talk about a little bit of a distribution system management program. You have to maintain a minimum of 20 PSI distribution system. Basically, majority of the utility maintaining about 50 to 60 pounds of pressure. You have to monitor the pressure throughout the distribution system at a key location and with alarms, basically, so you know at any place the pressure goes down, and you need to know that. This also provides a key indicator to if you have a large water main break, and so it gives you sort of a right-of-way indication. You might have some problem in the distribution system, and you can monitor on your SCADA basically to figure out what's going on. Once you have alarm in the distribution system, it gives you anything abnormal happening, and you can respond to it right away. The G200 calls for a comprehensive backflow prevention program. And it says that the backflow prevention program has to be fairly comprehensive, and at the minimum of the minima, it needs to meet AWWA Manual M14. Is to also, in addition to that, comply with all the state and federal and provincial regulations. Standard also go to quite a few into permeation prevention program, and it says if the utility have some sort of a water main, basically, which are not metallic, they need to be protected from any type of organic or solvents or any contaminant sites, because studies have shown that all this, these kind of contaminant can leach into the water mains. So it talks about not only having that, but also having a sampling program where you can go systematically on a routine basis, sample the water distribution system, water quality to make sure any of this contaminant happen to leach into in our water mains or not. That could be a plastic pipes or PVC pipes, C900 or HDPE pipe or any other type of pipe, basically. In terms of water losses, the G200 talks about having a comprehensive water loss control program. It talks about doing the water loss control surveys, and for the surveys, you got to have an annual goal, how much surveys you do, what your unaccounted for water losses are. You have to document it. You have to have a detailed action plan to respond if the goals are not met. Every utility should have a goal to a certain amount, and you have to have a certain amount of estimated leakage that express leakage in terms of gallons per day per mile of your distribution system. And you want to reduce this leakage. If you have a goal for 10%, and then you want to make sure you want on a path to continuous improvement to reduce it 9% until you're continuously improving it. Your unaccounted for water should be monitored. Your revenue and non-revenue water should be monitored, and action plan to be prepared if your goals are not being met. Talking about a distribution management program in terms of a valve exercising a replacement program, the standard goes in quite a bit of detail into setting up a goals of exercising a valves based on how many valves you have in your distribution system or transmission system. It also talks about every transmission valve should be exercised regularly, and you need to develop a critical valves list. Critical valve list should be prepared based on the important distribution system to the customer nearby, dialysis clinic, hospitals, in terms of businesses, or it's a critical business which relies on the distribution system, unlimited water supply, and the quality. You want to make sure those valves are exercised more quite often than the other ones. Goals for the number of distribution valves to be exercised annually, and also what you can do is you can also integrate the exercise of the distribution valve with the unidirectional flushing program as a preventative point of view. Again, you have to collect the data. When you exercising the valve, you have to do that condition assessment on the valve in detail and find out the status of the valve and have that some sort of a system where you can manually or basically you have some database program GIS system where you can put the condition of the valve on a GIS system, then you know, and the status of the valve. Condition of valve could be consist of anything inoperable, operable, good, very few. You could develop your own assessment codes, but also it's extremely important you know the status of the valve. Is the valve is closed or valve is open, and it's to be readily available to all the operators in the distribution system. Again, you got to have a written procedure for action if the goals are not attained. If you're not achieving those goals you are set for the operation of transmission and distribution valves. And I talked about the critical valves on the distribution system exercising on a regular basis. Its frequency is a lot more often than the rest of the valves. The fire hydrant maintenance and testing goes along with the valve exercise program if you are incorporating them into that unidirectional flushing program like we do. Again, you got to set the goals. In my opinion, it's a good idea to set a unidirectional flushing program, and it's about 3-year program where you can exercising all the distribution valve every 3 years, and you can exercising all the fire hydrant every 3 years, and you can do the transmission valve every year, or if you can every year, at least more frequency often than the 3-year period. In addition to that, you got to have a procedure and a protocol so how to operate the fire hydrant and also who operates the fire hydrant. As you know, the fire hydrants are mostly operated by doing the fire operation by the fire departments. In our situation, we have 13 different fire departments. We have to have a close communication with all the fire department. It's the onus on us to train the fire department folks. Basically, they know how to operate it properly, don't cause any damage to a distribution system while they're closing and opening those fire hydrants. As you know, in the fire situation, firemen are trying to do their job the best ability. Their objective is to open the fire hydrant as fast as possible. And of course, Doing so, it can damage the distribution system, cause a main break, and so forth. So you got to have a communication with the fire department, the fire districts, so you can train them and make sure they do it the right way. In addition to that, the standards talk about fire flow testing requirement. Make sure your all fire hydrants meet the minimum 4 requirements, and they're color-coded and as the NFPA rules and regulations. So when the fire department goes there, they know what kind of flows and pressure they're expecting from the fire hydrant. Okay, with the standard talks about in terms of management program with the material in contact with the potable water. I think this is basically a self-explanatory. Anything you use in a distribution system should comply with AWD standards and NSF standard 61 or the appropriate standards. You can go above that, but you cannot below this. In terms of metering, meter the volume of the water into the distribution system is required from the water treatment plant or you're a wholesale customer if you're a wholesale customer utility. You have to track the annual volume to be determined daily and maximum peak flows. You have to measure devices you use in the distribution system should meet the AWD standard. And the standard calls for the routine testing of all the meters you are using in the distribution system, whether it's a large customer or small customer or residential customer. And has to be recommended, you follow the recommended procedure as per identified in AWWA Manual M16. In addition to the standard talks about there should be a program to replace these meters if it's defective or at a certain interval. As you know, with time, the meter will under-register and you're going to have revenue loss. And those guidelines are identified in AWWA Manual M6 and the standard asks you to follow those. In terms of flow requirement, there's a requirement in the standard that you have to monitor the maximum daily demand, peak day demand, and also be capable of delivering fire flows for individual and public fire requirements. And you got to have enough capacity required to meet those demands. In terms of external corrosion, the standard calls for a system for recording and reporting pipeline leaks and breaks and information. Every time you have a main break, you're exposed to basically to a water main. You have the opportunity to do a condition assessment in terms of mechanically or in terms of visually, or you can take some testing required. Do if you want to do that. It's up to you. At the bare bone, you got to collect the data based on the location, the material, the pipe size, type of leak or break, visual assessment of the surrounding soil type, and the condition mains are good, bad, corrosive, corroded, or not. Pipes depth, and the saturation condition of the soil, where it's going to saturate. That's a bare minimum, but I recommend doing a lot more, doing the analysis, and that kind of analysis data you can use in rehab and replacement of distribution system program down the road. In terms of when you are expanding or rehabbing or doing it in the distribution system, you got to have a design review of water quality. They should have detailed policies and procedure. There's a standardized design review procedure required in the standard. Those procedures should have a protection of water quality is number one. And then doing that also, not only that, doing the design phase of it, also in terms of installation phase also. You have an accurate record of all the components and the distribution system. As you know, most of the utility, they have a good plan, but sometimes those plans are not 100% accurate. As-built drawing is a bare minimum must, and you got to have basically, anytime you do any type of modification to a distribution system, there's a requirement for as-built drawing as accurately as possible. And this information is need to be available on a GIS system or manually to the operators who are operating the system for you. The G200 also talk about in some energy management. It identifies what kind of energy you're using right now and basically provides opportunities, basically how you can reduce your energy consumption. You got to identify wherever you use the energy, what our trends are, how you track on the time, and how we can basically reduce the energy usage in the operation and all in the facilities you're maintaining for the distribution system. In some facility operation and maintenance, I'm going to talk about a little bit of a treated storage facilities. It talks about minimum capacities. Basically, the capacity has to be minimum to meet the needs of the distribution system. There's a minimum operating level identified in the standard. There's a fire flow requirements and the emergency storage requirement in the standard. You got to meet those requirements. And there's a specific site-specific condition in detail in the standard calls where you have to meet. Standard also talk about operating procedure. Every operating procedure has to be written, not just a verbal. In terms of a bare minimum, we had a water level fluctuation, the storage facilities, and turnover rates. You have a goals to reduce water age. You have written policy of a target turnover rates. As I would talk about, currently we are losing a lot of our experienced operators, and we got to retain the knowledge and expertise in your organization. There's a major brain drain going on. In the past, we never kept up to date to the documentation. So we want to make sure all the good information we have in the operator's mind right now, we can download it to the younger operators. So that's why everything has to be written, documented, and written in a language an average operator can understand and comprehend. The inspection and the standard also talk about inspecting all the facilities, and you have a facility, you have to be inspected. You have inspection programs. It talks about how often you inspect them, what the detailed procedure you're going to use. They should be recommended by all the manuals AWA produces, also with the manufacturer's recommended procedures. And you have to maintain all the records every time you inspect the facilities. Standard also basically says you have to make sure you inspect this facility reservoir and make sure they're safe and they're secure. This inspection program should include features including routinely inspection, daily something, or weekly, or periodically, monthly, quarterly, or annually, and thereafter. Similar to the other facilities, the reservoirs, standards also talk about pump station operational maintenance. Again, it's a major emphasis on operating procedure. Again, I'm talking about written procedures. You have operational log, inlet pressure, discharge pressure, individual pump runtime, flow rate, for example. And then your maintenance program. Every time you do a maintenance on every equipment, you got to have a documentation. You have written procedures. Make sure it's done by the qualified people, and they're following the qualified policy and procedure SOPs as recommended by the manufacturers. And it talks about the comprehensive preventive maintenance program of all the pump stations and keeping all those records and rehab and replacement program. Again, I'm talking about records shall be document all inspection, any service performed of any pumps and any of the facilities associated with it. The standard will go into a little bit more detail in terms of operation maintenance of pipeline rehabilitation replacement program. Once you install a distribution system, it's going to stay as is for a long period of time. As you know, you have to rehab it, replace it. You're talking about a program in detail for evaluating existing portion of the distribution system. Condition assessments are a must. We use in Charleston 17 parameter condition assessment. Based on this condition assessment, we have a comprehensive computer program which evaluates and prioritizes our pipeline rehab and replacement program. Research Foundation has done quite a good job. They have a lot of information available to them. Every utility should use that, and the standards calls for it. Some of the records you have to keep to have these kind of programs. You have the system maps. You have to find a long-term history of leaks and breaks, repair type, pipe condition assessment, joint condition assessment. You have to find out fire flows, C-factor tests, progressive gauge, pressure gauges, other pertinent data you collected remotely or manually. In addition, environmental information of location, the hazardous material on site, the soil condition, what's going on. You got to have proper separation between potable lines and other pipeline, and old stuff, and any hazardous material sites you have to make sure keep in track. In terms of a main break, you got to look at the goals in terms of a brakes of 100 miles per year or brakes per 100 kilometers per year for the Canadian France and over the distribution system. You can collect as much data as possible, apply that data to existing distribution system, and find the worst pipe or what we can do. Once you find the pipe, if something needs to be done, then you have to apply the criteria, Can I replace it or rehab it economically? So and apply whatever you need to do. So that has to be done comprehensively, and that's what standard calls for. That's basically talk about this. Keep going in. Basically, once you rehab and replace the distribution system or any of the distribution added or any type water main has been exposed to the outside environment, and cut and replace the water pipe during the maintenance activities or new construction, you have the standard calls for disinfection of all the pipes. It has to be done as per the AWWA standard, and you have backdate testing to be done as per NCAWC 651. While you're disinfecting the mains, you have superchlorinated water, you have to dispose it adequately, and that disposal of those kind of chlorinated water should be accordance with all the rules and regulation, and standard goes quite a bit in detail. The last component of the distribution standard basically for the distribution system operation management is that you need a documentation. You have to define all the critical activity you're performing on your distribution system into preventive maintenance and corrective maintenance. You have to create a written procedure for each of those. You have a training component built into it. Each of those policy and procedure has to be available to all the operators and all the employees, and those people, what the job they're doing, should be adequately trained on them. Then you have a record-keeping system to measure the compliance with distribution system, and basically the documentation could include quality policy and quality objectives, what you're trying to achieve in your distribution system. You got to have a standard operating procedures manual which lists all the procedures, and these procedures has to be prepared as per the in recommendation with the manufacturers and as a collective, sitting down together with all the operators and use everybody's brain, and it will be a consensus operator procedures. Any procedure required by this standard needs to be documented and available. Document and ensure effective planning, operation, and control in this process. Planning is the key to standard. Everything you do is as a standard. You have to plan, do it. We call it plan, do, check, act, basically. You plan it, then do it, you check which you do it, then act on top of that to make sure anything go right or wrong, and do that self-assessment and keep doing it, and you at a continuous improvement cycle mode, and you keep improving it. And you record everything that you did as per the standard. The verification basically required, you had done all those things, you will make sure the most important resource in the distribution system is our people. The personnel performing the work in the distribution system should be competent on basis of appropriate education. They have a licensing requirement, what license they need for distribution system. They have adequate training. They have all the skills, and their testing requirement make sure they're keeping this knowledge in their head to make sure they're performing the job to the peak. As you have experience as required by the governing agencies, whatever you need. Okay, applying that standard, what you can get out of it. I think Eva talked about all the good things. What do you get it for me? It just shows continuity and performance optimization of doing. It guarantees development of standard operating procedures. Then we have a brain drain. Provides a means to keep the institutional knowledge after employees' retirement. And the biggest of all, allows to maintain safe performance based on good practice and not for just like Eva talked about. I truly believe in that. Thank you.
All right, thank you, Ken. And for the folks on the webinar, you can, again, use the questions panel if you want to submit any questions. We've got a couple here for Ken. Ken, can you identify what the corrosion-related byproducts are, and do you consider dissolved inorganic carbon a corrosion-related water quality parameter?
Basically, you have to, there's quite a few there, and in Canada they have done in Quebec they have quite a bit of research study. There's a AWAS studies recently done. They identify 100. So there's a huge list. I can't go over it right now. The best thing to do is any byproduct you see in the distribution system, basically you can monitor it. There's a detailed list, but I will recommend monitoring of lead and copper rule as requirements with bare minimum. You have to do that. You can alkalinity. You have a lot of list parameters are listed. If you go to standard, you can list it. And there's a lot of byproduct comes in, basically nitrogen bacteria. There's a lot of other things you can look at it by. You can do it inorganically, organically, but I don't have time to go through the detail right now. But if you can give my email or number, they can call me. I can discuss in a lot more detail what do you manage. In addition to that, reason I don't want to mention specific stuff over here, we got a lot of controversy about it, what we shouldn't do that. There's a lot of research going on. So I can give the practical point of view, what basically the first indicator parameter you can monitor to tell your distribution system if you had a problem or not.
All right, great. Thank you. And I'll put you guys in touch if you need to follow up
Please.
on that with more detail. Another question, referring to the pipe rehab replace slide that you had, does the guideline recommend collecting number of breaks and response time to repair for each pipe diameter to be able to qualify for the losses for the M36 water audit analysis?
Well, I think so, yes, but basically right now we have moved, if there's AWW had, the best way to do is I'll say that AWW have a new water audit, basically a software. I recommend every utility to use that software, which is free. It's available. I think EPA funded it, and use that software. That gives you a little bit more detail what you need to be done in terms of revenue, non-revenue water. In terms of unaccounted for water, what we do is we have every time a main break, we estimate every time any water is lost through the distribution system. We estimate it. If we can't estimate it, we have a monitor it and calculate based on what you do. Every utilities do it a little bit differently. So I can't go into too much detail, but I would recommend AWW water audit software. That's the best way to go, and it's available for free. And it's self-explanatory. You can use it. And if you have more questions, you can let me know. I can go into a little more detail. That's what we use, and we've been doing it for a long time.
All right, excellent. We only had a couple of submitted questions. And we're getting right up to 3 o'clock, our close time. So with that, I just wanted to thank everybody for attending today's webinar. As a reminder, we have a third webinar scheduled for this series on source water protection, and that's going to be scheduled for May 2nd at 2 o'clock. We hope everyone will join us for that, and then we'll be posting a recording of this webinar along with slides to the new ASDA website, and we'll announce their availability once they're up. So thank you again to Khan and to Ava, and thank you all for joining.